So welcome students to my channel once again. Today I have brought this question for you all. Just see the question carefully. Now the question has been given like this, that if one root of the quadratic equation ax square plus bx plus c is equal to 0 is equal to the nth power of the other root, then show that a into c to the power n whole to the power 1 by n plus 1 plus a to the power n into c whole to the power 1 by n plus 1 plus b is equal to 0. Okay, note the question carefully. If one root of the quadratic equation ax square plus bx plus c is equal to 0 is equal to the nth power of the other root, then show that a into c to the power n whole to the power 1 by n plus 1 plus a to the power n into c whole to the power 1 by n plus 1 plus b is equal to 0. So it has been said over here that if one root of the quadratic equation is equal to the nth power of the other root. Clear? So I will take the two roots as, okay, let alpha, and it has been said over here that one root of the equation is equal to the nth power of the other root. So I will take two root as, let alpha and alpha to the power n be the roots. Let alpha and alpha to the power n be the roots of this equation ax square plus bx plus c is equal to 0. Okay, so then what can I say? That we know that the sum of the roots alpha plus alpha to the power n, what will be? Alpha plus alpha to the power n will be minus b by a, right? We'll name this as equation 1, and product of the roots, that is alpha into alpha to the power n, will be c by a, right? So we can write this as alpha to the power n plus 1 is equal to c by a. We'll name this as equation 2. Clear? So now from equation 2, so equation 2 is what? That alpha to the power n plus 1 is c by a, right? Now you can write alpha will be what then? Alpha will be c by a to the power 1 by n plus 1, right? Alpha will be c by a to the power 1 by n plus 1, and alpha to the power n will be c by a to the power n by n plus 1, right? Now we'll put these two values of alpha and alpha to the power n in equation 1, right? We have got the value of alpha and we have got the value of alpha to the power n as well, right? Now we'll put these two values in this equation 1. So we'll write like this, putting alpha is equal to c by a to the power 1 by n plus 1 and alpha to the power n is equal to c by a to the power n by n plus 1 in equation 1, right? So what we'll get if we put these values? Alpha, we'll put alpha like this, c by a to the power 1 by n plus 1, right? Plus c by a to the power n by n plus 1, right, is equal to minus b by a. Clear? We will write this, we can write this line like this. We'll write c to the power 1 by n plus 1, a to the power 1 by n plus 1, right, plus c to the power n by n plus 1 a to the power n by n plus 1 plus b by a. Here it has been written as minus b by a. We are bringing this minus b by a from right hand side to left hand side. So it will be plus b by a is equal to 0, right? Now we will multiply this whole left hand side and whole right hand side with a. We will multiply the left hand side with a as well as the right hand side with a, right? So how? Just see. C to the power 1 by n plus 1, a to the power 1 by n plus 1. We will multiply both sides by a. C to the power n by n plus 1, a to the power n by n plus 1, right? Now plus b by a. We will multiply this whole with a. So we have to multiply the right hand side also with a, 0 into a. Okay. So what will happen now? C to the power 1 by n plus 1 into a. So a to the power 1 by n plus 1 plus c to the power n by n plus 1 into a by a to the power n by n plus 1 plus b by a into a is equal to 0 into a is 0. We all know that. So what will happen here? C to the power 1 by n plus 1 into a to the power, when the bases are same, power will get subtracted, we all know, 1 minus 1 by n plus 1, right? Plus c to the power n by n plus 1 into a to the power 1 minus n by n plus 1, right? Now here a will get cancelled, so plus b is 0, right? So what will happen next line? C to the power 1 by n plus 1 into a to the power n plus 1 minus 1 plus c to the power n by n plus 1 into a to the power n plus 1 minus n plus b is equal to 0, right? So plus 1 minus 1 will get cancelled. Okay. So c to the power 1 by n plus 1 into a to the power n by n plus 1 plus c to the power n by n plus 1 into a to the power, minus n plus n will get cancelled. So it will be 1 by n plus 1 to the power 1 by n plus 1 plus b is equal to 0. So what will write in the next line? We can write like this: c into a to the power n whole to the power 1 by n plus 1. c into a to the power n whole to the power 1 by n plus 1 plus c to the power n into a whole to the power 1 by n plus 1 plus b is equal to 0. But we have to prove that a into c to the power n. So we can write this step, we can write this whole number is c to the power n at first. So we will write like this, we can write like this, that we can write this as like a into c to the power n to the power 1 by n plus 1 and then this number. We can write like this number as a to the power n into c 1 by n plus 1 plus b is equal to 0. So we proved. See, a into c to the power n whole to the power 1 by n plus 1, a into c to the power n whole to the power 1 by n plus 1 plus a to the power n into c whole to the power 1 by n plus 1 plus a to the power n into c whole to the power 1 by n plus 1 plus b is equal to 0. So we have proved the identity. Clear? Thank you.